Hi all, today we'll discuss about an important concept in IO organization. It is called input and output interface. Remember, if this is my CPU or computer and this is a peripheral device, then this peripheral device communicates with the CPU using a module called IO module, and this is called link. The communication between the peripheral device and IO module is referred as a link. Now we discuss about an IO input and output interface, that is IO interface. It provides a method for transferring the information between internal storage. Internal storage means, see, as I said, in CPU contains two memory elements. One is main memory and registers, and external IO devices. So this is referred as internal memory. So from now onwards, if you refer an internal memory, that means it is nothing but it could be a main memory or CPU registers. Remember, though the external hard disk, that is secondary memory, resides within the CPU, it is not called internal. So the internal storage means, why it is not called? Because the processor cannot directly access the external device or a hard disk. The process can directly access only CPU registers and main memory. So this is referred to as internal memory. Now this is internal storage and external IO devices. External IO devices means internal hard disk or external hard disk or USB drive, pen drive, or any DVD, anything, any external IO devices, printer, scanner, plotter, monitor, keyboard, mouse, joystick. All these are external IO devices. So let's take an example of a keyboard, an external device called keyboard. Using keyboard, when user enters the data, that data has to be transferred to main memory or register, right? So in between there sits an interface which is called IO interface. So it is, this is my main memory and these are the CPU registers and these are external IO devices. Then there sits an IO interface which provides a method how to transfer, how to get, it receives the data from input device like keyboard and send it to main memory or registers, something like that. So peripherals connected to a computer need special communication link for interfacing them with the central processing unit. As I said, this is called link. A special link has to be established. So the IO interface. The purpose of this communication link is to resolve the differences exist between the central computer and each peripheral. So what is the need for IO interface means? This is my internal memory, main memory, CPU registers. These are external IO devices. Why you need an IO interface means there exist some differences, just to resolve some differences. Let's take an example of a speed. The speed of a keyboard is very much slow compared to the main memory. If the user enters one word per minute and the memory write operation, whereas memory write operation takes 10 nanoseconds, and whereas the user enters a word in one word per 60 seconds or one word per minute, then there is a speed mismatch. So we need an interface which compensate the speed differences. This is called IO interface. Next we see what is the so what are some differences, why we need IO interface, what are the differences between external IO device and internal storage. We see the difference between internal storage and external IO devices. See, the peripherals are electromechanical devices or electromechanically and electromagnetic devices. This is important. IO devices are electromechanical devices in the sense keyboard. User has to manually press the key. It's a mechanical work. Then it converts into some signals and sent to the IO interface. So the peripherals are electromechanical or electromagnetic devices, and their manner of operation of the CPU, their manner of the operation of the CPU and memory, which are electronic devices, are different. See, the main memory is an electronic device, CPU registers are electronic devices, whereas these external IO devices are electromechanical devices, not electronic devices. The main memory or the processor or CPU register, they are electronic devices. The speed of these electronic devices are entirely high or different from electromechanical devices. The speed of the electromechanical devices are very slow, very low. So it is required to have an IO interface here. This is the concept called what is the need for an IO interface. If somebody asks what is the need for an IO interface means, the IO interface is required to communicate between the external IO devices or peripheral devices and internal storage, that is main memory and CPU register. Why it is required to have an IO interface means electronic peripheral devices or external IO devices are electromechanical and electromagnetic devices. Their speed is very low when compared with the internal storage such as main memory and CPU registers, which are electronic devices, and their speed is very high. So it is required to have a signal. The signal that comes from these external devices is also different from what internal storage expects. So the signals has to be converted. So next, the data transfer rate of the peripherals is usually slower than the transfer rate of CPU, and consequently a synchronization mechanism may be needed. Yeah. So the need for IO interfaces means the signal that comes from electromechanical devices are different from the signals that expects electronic devices. So we need to convert the signals that are coming from electromechanical devices, convert and send to internal storage. For that we need to have an interface. The first reason is, since external devices are electromechanical or electromagnetic devices, the data they send in the form of a signal which is entirely different for electronic devices. So these signals has to be converted, translated into a form which electronic devices can understand. For that purpose we need to have an IO interface. And the second reason, this is the first reason, and the second reason is that the speed mismatch. The data transfer rate of peripherals is usually slower than the transfer rate of the CPU. So, and consequently, a synchronization mechanism is required because when the user is capable, the user might be capable of entering or typing one word per minute, whereas the main memory performs a write operation in 10 nanoseconds. So the data transfer rate is entirely different. So there is some synchronization mechanism is required. That is the job of I/O interface. So the I/O interface performs conversion of the signal and compensate the data transfer rate differences. For that reason, we require to have a I/O interface. Next, another third reason is the data codes and formats in the peripherals differ from the word format in CPU and memory. That's a simple reason. When you enter your name in a keyboard, the code that is sent from this keyboard is entirely different from what main memory couldn't understand. So the data codes and formats are entirely different. It depends upon the manufacturer. So it has to be converted into the format which your internal storage can understand. So the data codes and formats are different. Peripherals, how they send the byte or some block means group of bytes, but CPU or main memory expects some memory word may be a 32-bit memory word or 8-bit memory word. The peripherals will send byte wise, 1 byte, 2 byte, 3 byte. But if you see, if your main memory, if this is my internal storage, this is main memory, these are CPU registers. If the main memory, the word size in main memory, let's assume it is 64-bit. That means 8 bytes. Whereas your keyboard might be sending 1 byte. So what is the job of I/O interface? Wait for 8 bits entered by the user, accumulate this and then send. So like that, the data format and data codes in the peripheral devices are different from the main memory and CPU register, which together call internal storage. The operating modes of the next reason is the operating modes of the peripherals are different from each other and must be controlled as not to disturb the operation of other peripherals connected to the CPU. So it is also a job of I/O interface to handle all the I/O devices because all the I/O devices are not manufactured by the same vendor. It might be some devices, each device might be manufactured by a separate vendor. Then in this case, it is required to control those I/O devices. That is the job of I/O interface. So if you come a question like what is the need for I/O interface means, the first reason is that there is required to peripheral or I/O devices are electromechanical devices and electromagnetic devices, and their communication or the signal they send is different from what electronic devices expects. So this signal has to be converted. For that we require to have an I/O interface. Second reason, the data transfer rate of these peripheral devices or external I/O devices are different from the data transfer rate of main memory and CPU registers. The data transfer rate of peripheral devices is generally very low when you compare with the electronic devices. So it is required to have IO interface. So the job of IO interface is to synchronize or balance, compensate the speed difference, data transfer rate between these two things, that is external device and internal memory. Next, data codes and formats of the peripherals are different. As I said earlier, keyboard might be sending 1 byte by byte, 1 byte, whereas your main memory expects 8 bytes, something if it is a 64-bit system. Next, the IOU interface also has to manage or control all the input devices connected to the CPU, because they are manufactured by a different vendor. So it is required to control. They should not disturb other IO devices. Next, so to resolve these differences, the computer system include a special hardware component between the CPU and peripherals to supervise and synchronize all input and output transfers. These components are called interface units because they interface between the processor bus and the peripheral devices. So, to resolve all these differences, we need some special hardware component. Remember, IO interface means, so far we are referring IO interface. First thing is that it is a hardware. What it contains? Interface units. So, IO interface are nothing but some special hardware components, and these special components supervise and synchronize all input and output transfer. These components are called interface units because they interface between the processor bus and peripheral devices. Now we see the function of this IO module or IO interface. The first thing is that it has to control and timing, coordinate the flow of traffic between the internal resources and external devices. First, it has to control the data transfer, coordinates the flow of traffic between, traffic means data. Next, processor communication involves command decoding and data status reporting, address recognition. So it may your IO device, IO interface may receive the signals from, or the control signals from control unit, which is part of the processor. So if this is my control unit which resides in the processor, ALU and registers, if this control signals, it can send some control signals to IO interface, which contains some interface units, which is nothing but as hardware. They will receive the control signals, so that involves command decode those signals such a way that your IO devices can understand, and send the status report, do some address recognition. So this is the job of IO module or IO interface. Next, I have error detection. Detect and report transmission errors. Detect and report some transmission errors, because of the wire communication or damage of wire communication, something like that. It may possible to have an error while transmitting the data. So it is also the job of IO module to detect such errors. Data buffering. This is an important concept. Data buffering. Perform the needed buffering operation to balance the device and memory speeds. So earlier we discussed that when we discussed about the need for an I/O interface, we said that data transfer rate of I/O devices are very low when compared with the data transfer rate of processor or memory, main memory and CPU registers or processor bus. So how it compensate the speed mismatch means it maintains a buffer, data buffer. Buffer is nothing but a temporary storage area. See, the example is when the user enters a keyboard, some word using keyboard, and the I/O interface or interface unit related to that keyboard maintains a buffer, and it waits that until it receives 8 bytes of information, because the keyboard is sending the data byte by byte. For example, if it is sending 1 byte at a time, the I/O unit receives that 1 byte, stores in a buffer, and waits for another next byte to come. Like that, once it receives 8 bytes, then it transfers that 8 bytes to main memory using some processor bus. So this is called data buffering. This is a very important concept. So if this is my main memory and these are CPU registers, if this is my main memory CPU register and its length is 64 bit, so the I/O interface, which contains interface unit, maintains a buffer. So when the keyboard enters 1 byte information, this information is stored in this buffer until it reaches 8 bytes. Then this interface unit will send the 8 bytes. So it accumulates all the 8 bytes that is coming from keyboard. This is called data buffering. Device communication. It involves commands and status information, some data. It also communicates with the I/O device, whether it's an active one, what is its status. So these are the job of the functions of I/O module. Next we see the structure of this I/O module. It's very important to understand the structure of this I/O module. See, this structure contains uh, some block. First you should understand that these first understand this component: external device interface logic. So this is an interface to external devices. That means external devices are connected to here. It's an interface. And so these are all different types of external device interface logics which are connected to external devices. Then this is called I/O logic. This I/O logic receives the address lines or control lines from control unit, and it will send to concerned external device interface logic, which will send to concerned external device. Once external device sends the data, if this is my keyboard, So initially the processor sends a address line that user wants the program. If you write a program like scanf, then user has to enter the data using keyboard. So processor issues an address line and also says some information using control line. So based on this, IO logic will send it to concerned external device interface logic. This case, external device interface logic for keyboard. So when the user enters the data, that will be transferred to registers. See, we have data registers and status and control registers. So this data register is called buffer. So this is how uh, the IO module works. Let me explain. It's very important to understand this. So these are the the whole thing is in hardware. The whole thing is called a special hardware. So these are external device interface logics which are connected to, each one is connected to one peripheral device. For example, this might be connected to keyboard. This is connected to monitor. This is connected to mouse. So each one receives a signal from this extra hardware circuit called IO logic. So the IO logic receives the signals from the processor or control unit. Once the user enters the data, that has to be stored in some registers. See, buffers are nothing but, now this is called a buffer. So buffer are also registers, temporary registers, and there is a special status and control register. So this is about IO module structure. Now we discuss an important concept called synchronous and asynchronous data transfer. See why? Before going to discussing about this data transfer, we really need to understand why it is required to learn about data transfer. Because see, a lot of data transfer is happening main memory, CPU registers. If this is an IO interface, which is an hardware which is connected to external devices like keyboard, mouse, joystick, monitor, speaker, printer, scanner. So these are all data transfer. So here a data transfer will take place. Here data transfer main memory to IO interface or IO interface to main memory. IO keyboard to IO interface or IO interface to printer. So here various kinds of data is being transferred. Various types of data transfer is happening. So it is really important to discuss the different types of data transfer. And there are two types of data transfer, that is synchronous and asynchronous data transfer. So let me draw the picture. Once again, this is my main memory. These are the CPU registers. This is an IO interface. And these are the peripherals. Peripheral devices. So here where kinds of data transfer happens. These all lines indicates data transfer. So it is important to understand different kinds of data transfer. Before going to data transfer, we will see how data transmission happens. The data transmission refers to, what is data transmission means? Refers to the movement of data in the form of bits. So data has to be transferred in the form of bits. It occurs between two or more digital devices. Simple transmission. For example, if this is my CPU and this is monitor, this is a keyboard. So from keyboard to monitor, CPU to monitor. So this is called data transmission. Serial interfaces, one bit at a time. So if you are data transfer, there is a special type of transfer called serial interfaces, where one bit of information is sent, bit by bit data is transmitted. Next we see the data transfer types. Data transfer can happen in two ways, that is parallel data transmission, serial data transmission. Serial data transmission is again divided into two, that is synchronous and asynchronous. So we are dealing with this one. So our topic is synchronous and asynchronous data transfer, which is called, both are called serial data transfer. So the data transmission is of two types, parallel and serial. Our topic, synchronous and asynchronous data transfer, transmission, both are same words, comes under the category serial type of data transmission. First we see what is parallel transmission, how it works. All the bits of a byte are transmitted simultaneously on separate wires. See, this is my sender and this is the receiver. So if I want to send 8 bits of information from sender to receiver, I need 8 wires. So these 8, each wire carries 1 bit of information. So this is called parallel data transfer. So this diagram shows that 8 wires are used simultaneously to transfer 8 bits of digital data. It is very simple to understand that if I want to transfer 16 bytes, 16 bits of information, either I need to have 16 lines or send 8 bits in 2 phases. So this is called parallel transmission. So you can easily understand the disadvantage of the parallel transmission is the transmission of n bits will require n number of wires. As I said earlier, if I want to transfer 32 bits from sender to receiver, if I want to transfer 32 bit, I need to have 32 wires, which increases the users of these wires will be too difficult to handle. It's very difficult to handle, and it increases the cost. So this is the disadvantage of parallel transmission. So the solution is serial transmission. So in serial transmission, all the bits of byte are transmitted serially, one after the other, on the same wire or single wire. So this is my sender and this is my receiver, and again sender wants to send 8 bits of data. Then it can be sent over a single line. How? One bit by bit is sent to, the 8 bits are sent one after the other. So we need only one line. But if you observe that there is a converter here parallel to serial converter. This is serial to parallel converter. This is required. Why? Because the receiver has to receive all 8 bits at a time. So the goal is when sender sends 8 bits of information, all these 8 bits should be received by receiver. So for that we need to have parallel to serial converter at sender side, because the sender has 8-bit data. This parallel to serial converter converts this and sends one bit after another bit, and here it receives a serial to parallel converter and it accumulates all the 8 bits and send to receiver. So this diagram shows that one wire is used to transfer 8-bit digital data. Now the serial transmission, the serial transmission is more popularly used. Example, data transmission between computer and computer. So when computer in Ethernet, in network, in Ethernet, when one computer is connected to another computer via wire, it follows a technique called serial transmission. It is not only possible for devices at closer distances but also for far distances. This is how internet works, right? If you take an internet connection from any internet service provider, broadband service provider, they will give by a connection or wireless router, right? So the whole internet works on this technique called serial transmission. Now one can easily guess the advantage of serial transmission. Only one wire is required and it reduces the cost due to less number of conductors, because less number of wires are used. But remember, we are using parallel to serial converter at sender side, serial to parallel converter at receiver side. Then will not increase the cost? No. How? We will see. The disadvantage of serial transmission, the speed of the data transfer is low. Obviously, when you send bit by bit, it takes hell lot of time when you compare with parallel transmission. However, to increase the speed of the data transfer, clock frequency needs to be increased. We'll see how. The goal is we have to use serial transmission, but the disadvantage is that the speed of this data transfer is very low. So it is required to, we need to compensate the speed. However, we need to increase the speed, and this can be done by using clock frequency. We'll see what is that clock frequency. Next, there are different types of serial transmission in data communication. Timing control of the reception of bits is important. So there are two methods of timing control reception bits. So one is synchronous. What are the two types of serial transmission means? One is synchronous transmission and another one is asynchronous data transmission. How they differ means they differ on the timing control of the reception of bits. How you are receiving bits. Based on that, the serial transmission is there, can be categorized as synchronous and asynchronous. First we see synchronous data transfer. Synchronous means at same time. Synchronous means same time. In this format of data transfer, the transmitter and receiver device are synchronized with the same clock pulse. So it's really important to understand what is meant by clock pulse, what is meant by synchronized. I'll give an example. If you see, if you go to any building construction site or house construction site, two persons are there. One person is standing at the floor nearby some bricks. The goal is he has to give that bricks, throw that bricks to other person who is at the first floor. So he will be throwing the bricks to the second person, and here when the first person throws the brick, the second person should be readily available. You should know when the next brick comes or will be thrown out. They follow the same timings, right? If you don't follow the same timings, or if they both are not synchronized, definitely the brick will fall down. So this is called the best example for synchronization. Here let's assume they both are blind persons. Then how to throw or then how to manage it means they will hear a bell ring for every 1 minute. Let's assume they have an agreement that the moment bell is ring, then the sender understands that he has to throw a brick. And the moment the bell ring here by the receiver understands that he will be getting the brick or data. So this bell is called clock. So there is only one bell shared by both sender and receiver. Similarly, there can be one clock, same clock, they can share the same clock, the both sender and receiver can share the same clock in synchronous. This is my sender, this is my receiver. The sender sends the data to receiver by looking at some clock pulse, something like bell. So they can have the same clock or they can have two clocks which are synchronized. If they are nearby, say if the both sender and receiver are nearby, they can share the clock. If they are at some distance, they can have two clocks which have the same frequency, which have same frequency. So synchronous means same time. Same time means the both sender and receive the bell at same time. They respond to the clock pulses at same time. So synchronous means at same time. In this format of data transfer, the transmitter and receiver or sender and receiver device are synchronized with the same clock pulse. So you should understand this word, synchronized with same clock pulse. Synchronized with same clock pulse. That means the both sender and receiver, once they hear the bell sound, they understand that sender has to send the data, receiver expects that receiver he will get the data from sender. This is meaning of synchronized with the same clock pulse. synchronizing with same clock pulse. It's a very important concept. It is used between the devices that match in speed. Yes, it's very important. This type of synchronous data transfer is used when they have same speed. In the earlier example, brick example, if once the bell has been ring, if the sender sends one brick and again he is ready to send another brick, before that receiver should catch it, hold it, place it somewhere and ready for the second brick. Otherwise what happens? Yes, the data will be lost. So the speed of the both sender and receiver should match, almost same. Then only synchronous kind of data transfer it can be implemented. Synchronous data transfer can't do. Synchronous data transfer. In synchronous transmission, data transmission is carried out under the control of common master clock. I tell you right, there is a common master clock for sender and receiver. There is a common master clock, or they can have separate clock also. It's not an issue. So data transmission is carried out under the control of common master clock. Bytes are transmitted as block in a continuous stream of bits. So here remember it is a serial communication, so we have to send bit by bit. How they are sent? As a continuous stream of bits. Because if you want to send 1 byte, you need to send 8 bits. These 8 bits are called one block. Transmitter and receiver operate at synchronized clock frequencies. Yes. No start and stop bits are used. No start and stop bits because they share same clock pulse. They share same clock pulse. No need of ideal time between data types. Continuously data can be sent because based on the clock. In synchronous transmission, timing of the signal is important.